All right, hi guys. All right, we're gonna do section 7.4 and 5 in the beginning of your packet. I'm gonna share my screen. So that packet, or that beginning of 7.4 starts, where does it start? Yeah, it starts on page 18, all right? So we're going to talk about two-way tables and Venn diagrams. A two-way table and Venn diagram can be used interchangeably. We just got to know how to fill it out. All right. So we have a Venn diagram. I'm kind of looking at this. It looks like this first circle is those who are taking a foreign language. The second circle is those who are playing a sport. And 14 is the overlap. It's those who are doing both. And 3 is those who are doing neither. All right. So that's kind of, I just have to interpret it a little bit first before I start filling out the two-way table. So the way you make a two-way table, all right, you put one circle, either you take a foreign language or you don't, and then you have a total column. Going across this way, either you play a sport or you don't in total, all right? So this is how I set it up. It doesn't matter what circle goes up or down. It's, you know, I could have flipped this around and it wouldn't matter. All right, so how to get 50 for a total? Well, if you add up all the numbers in the Venn diagram, so if I do 23, 14, 10 and 3, and if I add those all up, I get 50. So there's 50 people they surveyed. All right, and we're going to see kind of what we can do and how we can interpret this table. So to fill in the numbers, I need the first column, the first box here. I have to read this, the corresponding column and row. So the number who play a sport and take a foreign language. All right. So how many people play a sport and take a foreign language? That would be 14. All right. The next column, how many play a sport but do not take foreign language? Well, play a sport and only. So that would be this 10 guy here, right? 10. All right. Add those up to get the total. Okay. Now we're going to go to the next row here. How many do not play a sport? That means they're not in this circle here. And take a foreign language. So they only take a foreign language. That would be 23 of them. So this next one, how many do not play a sport and do not take a foreign language? So if they don't do either, that's these guys out here. So that's 3. All right. Once I have this filled in, I'm just going to do my totals. There's a lot of checks and balances. 23 plus 3 is 26. So you'll notice 24 and 26. Oh, guess what? It adds up to 50. That should happen this way too. All right, so 14 and 23 is 37, and 10 and 3 is 13, and you'll notice that that also adds up to 50. So I know I filled my table in right. If they don't add up to 50, then we've probably done something wrong. All right, so there's my table. All right, so I just filled in the table. I'm not answering any questions. You know, from this you can ask some simple probability questions like, what's the probability if a person picked at random, you know, does not play a sport? That would be 26 out of 50. There's a lot of probability questions they can ask from these two-way tables or from a Venn diagram. They really do the same thing. All right, let's do this. Let's go down. All right, so we're going to make a table, a two-way table for marbles or beads or whatever. This is pretty common problem. Let me clear this off. All right, a bag contains 50 beads. Some are round and some are star-shaped. Some of the beads are green, the rest are blue. So you see my two-way table, we've got color and shape in total, all right? So when I look at this, 50 beads, guess where that goes? Right here. That's total, right? All right, 30 of the beads are green. And of those, 20 are round, all right? So I've got 20 round green beads. So if they're round and green, I've got 20. Now I've got 30 total, so let's put that down here for the greens. So that means I've got 30 minus 20. I have to have 10 star shapes. Yeah, I can fill that table out. All right. 15 of the beads are star shaped. So I'm going to go to the star shape. Now I know that that's a total, right? So if there's 15 that are star shaped, that means 10 plus what is 15? That better be a 5. Okay. Now, once I start filling out this table, everything has to add to the totals. So now look at the bottom column here. 30 plus what is 50? Oh, that better be 20. Right? And then I know if I go down here, the numbers going down this way have to add to 20. So this had better be 15. All right, and I can add across this way to get a total. 20 and 15 is 35. And you'll notice when I add down this way, yeah, it adds to 50, so I know my table is right. So this tells me there's 15 round blue beads, 5 star-shaped blue beads, there's 20 blue beads altogether, so I can read the table once I have it all filled in, okay? All right, and they didn't ask me for any probabilities, so we're just gonna let that go. From these tables, they'll ask you probability problems. It looks like we've got a few things. All right, they're coming up, good. All right, so we're gonna fill in a two-way table now, and we're gonna use like probability. We're gonna figure out, what's the probability of something happening. Yeah, take it. All right, so let me fill in my numbers. 80 students are surveyed. That would be the total number, right? So I'm gonna put that right there. 50 of them are freshmen, so that's the total amount of freshmen, which means, of course, that 30 are not freshmen. I got that. All right, 30 of the students have part-time jobs. Okay, so that would be a total. So again, going down, this had better be 50 to add to 80. All right. The others don't have jobs. Okay, yeah. Okay, so 50 don't have jobs. 20 of the freshmen don't have jobs. So freshmen, no job would be 20. Okay, this is enough information to fill out the whole chart. All right, so reading across, 20 plus what is 50? So this needs to be 30. All right, going down, totals, what plus 20 is 50? That would be 30. And how many are not freshmen that have a part-time job? Well, we can see that that's going to be 0, because 0 plus 30 is 30. Okay, and going across, all my totals have to add up, which they do. Okay, across and down. All right, now once I have this, I can get probabilities, odds, information, stuff like that. Okay, so one student is chosen at random. What is the probability that the student is a freshman? So we have no limitations here. We know there's 80 students total, and if I choose a freshman, I've got 50 to choose from. So the probability would be 50 over 80. And if I reduce that, it's 5 over 8. If you want to turn it into a decimal, you can just plug it in your calculator, do 5 divided by 8. Where's my calculator? There it is. All right, 5 divided by 8. And I get 0.625. All right. So one student is chosen. What are the odds the student has a part-time job? Now, the way that I do odds, probability is, the way I think about it, it's the ways to get what I want over the total. The odds are the ways to get what I want over what I don't want. Okay, so the odds that the student has a part-time job. So let's go over here to part-time jobs. All right, so wait a minute, what I want, so there's 80 total. I make a little table here. How many students have part-time jobs? There's 30 that don't, right? Let's say it's a part-time job. So there's going to be 30 that do. Those that don't is 50, and the total's 80. All right, so the odds are the number of ways to get what I want over what I don't want. So the number of students that have a part-time job is 30, and the ones that don't would be 50. All right, so it's 30 to 50, or 3 to 5. It's how they write it. They could write it as 3 to 5 like this, or 3 to 5 like that, just with a colon. It just kind of depends on the professor. But the odds are the ways to get what I want over the number of ways to get what I don't want. Probability is what I want over the total. Okay. one student with a job is chosen. So what that means is once they specify something like that, I'm only looking at this row right here, all right? Only students who have jobs, there's 30 of them. What is the probability that the student is a freshman? Well, there's 30 freshmen out of 30 people have part-time jobs. So that's pretty much 100%. So that's going to be 1, okay? So when they specify something real specific like this, you only look at that category, okay? All right, 1 freshman is chosen. I'm going to get a different colored pen here so I don't confuse y'all. Freshmen, so we're only looking at freshmen now, right here, okay? What are the odds the student has a part-time job? So the odds, number of ways to get what I want over what I don't want. So the odds would be 30 have a job and 20 don't. So that would be 3 to 2. Okay. All right, so the thing with the odds, it's just the ways to get what you want over the ways to get what you don't want. Probability is what you want over the total. All right, you see how the tables can make all that stuff easy for you. You're just really reading the appropriate columns from the table. All right. Okay, so now we have a two-way table, but guess what? We get to fill it in. Okay. So let me annotate and let's see what we can do. I like blue. All right, 100 patrons. All right, so first thing I always do is put a total here. We're gonna have total. To a restaurant, we're asked about their preference for chicken versus beef and their preference for rice versus pasta. So we have a preference for meat, so we can do chicken or beef. We'll do that at the top. Rice and pasta. It doesn't matter what you put where. The rice and pasta could have gone up top, and the chicken and beef down bottom. Just put the categories. One is a row and one is a column. Okay, so once I have it labeled, out of 30 customers that preferred rice, okay, so a total 100. That goes right here. 20 preferred chicken. So 20 customers, that tells me like both rice and chicken. So this should go here, rice and chicken. 30 people that preferred rice. So that means the total amount of people that like rice would be 30. That would be right here. All right. And 20 that like both. All right, so now what we can do is fill some columns in. This has to be a 10, right, to add to 30. 30 plus 1 is 100. That would be 70. See, I'm filling in stuff as I go. All right, there were 60 customers that preferred chicken. So chicken would be this column right here, so that's a total. And I think I can fill everything in now. 60 plus what is 100? This would be 40. 20 plus what is 60? That would be 40. And 10 plus what is 40? That would be 30. All right, you can check it. 40 plus 30 is 70. See how everything adds up? We know we did it right. If they don't add up, we didn't do it right. All right, so what percent of customers prefer chicken and rice? So chicken and rice is this guy right here. It's 20 out of 100. So that's easy, 20%. Okay. What percent of customers prefer beef and pasta? So beef and pasta would be 30, again, out of 100, so that would be 30%. Okay? All right, so if you just put the labels on the tables, it'll all work out. All right, let's go down a little bit more. Okay, and now let's... Okay, we're going to do another two-way table. As each person entered the theater, Aaron counted how many of 105 people have popcorn and how many had a drink. So it looks like we got 105 total. Put my totals on there. Five people. Okay, so it looks to me like this table's too big. Let's see, Aaron, popcorn, how many had a drink? So we're counting popcorn and drinks. And that's it, right? So I think we have too many columns here. So what we're gonna do is we're gonna knock off this column. All right, total. And we're gonna knock off this column. We don't need that much space. So total. All right, so 105 people total. We have popcorn and drink. All right, so 105 people, how many people had popcorn, how many had a drink? Out of 84 people that had popcorn, so that's the total amount of popcorn, only 10 did not have a drink, so that would be 74, right, that had a drink. I do need 3 columns. Oh, sorry. All right, let's do it again. All right, so total. Oh, I know what it is. Okay, so we're gonna do popcorn. Either you can have popcorn or you can't have popcorn. That's how we're gonna fill it out. Or we're gonna have a drink, or we're not gonna have a drink. There we go. Now I've got it. All right, now I've got it. All right, so total 105 people. Okay, now we can fill out the table. All right. Out of 84 people that had popcorn, only 10 did not have a drink. So I know popcorn total, there were 84 people. And only 10 did not have a drink. So this would be 10 with no drink. So that means this has to be 74, right? All right. And I can fill this column in. I have to add up to 105. So I'm going to do that on my calculator. 105 minus 84. Yeah, 21. All right, so 21. All right. 6. So I've got that. Okay, 6 people walked in without popcorn or a drink. So 6 people, no popcorn, no drink. And I can now tell what this one is because this has to add to 21. So this has to be 15, right? And let me add up the totals across the rows. 74 plus 15 is 89. And 10 plus 6 is 16. Here's my check. This will better add to 105. So 89 plus 16, it's 105. So I know I've got my table right. Yay. So now I can just answer the questions. What percent of people did not have popcorn or drink? So percent is part over whole. So the people who didn't have popcorn or drink were 6. So it'd be 6 out of a total of 105. It's not 100 here, so I need to work that out on my calculator. So I'm going to take 6 divided by 105, and I get 0.057. I'm going to multiply that by 100. I'm going to call it 5.71%. Okay. All right. And what percent of people had popcorn but not a drink? So popcorn and no drink would be this guy right here. It's 10 out of, again, a total of 105. .095. We're going to multiply by 100 to get the percent. So I get 9.52%. Just round it to a couple decimal places. All right, so these are two-way tables. All right, which will help you with probability and odds. So just because I have a second, like if I ask you, what's the probability a person picked at random that they had, you know, well, the probability is the same as what I've been doing is a percent just multiplied by 100. What's the probability that, you know, a person who walked in had a drink and no popcorn? A drink and no popcorn. So a drink and no popcorn would be 15. So it'd be 15 out of 105. And that's your probability. You just have to, you can convert it to a decimal if you like. You just don't multiply by 100. And this one, 15 out of 105. is 0.142. Now, so again, they can limit this. They can say, what's the probability a person had popcorn given they had a drink? Okay, so we know they had a drink. That's known. So we're only looking at this. So the probability they had popcorn, given they had a drink, popcorn, it's 74 out of 89 people. So that would be the probability a person had popcorn if they had a drink. Okay. And again, the odds are what I want over what I don't want. So what are the odds? Let's say a person has a drink. Okay, so how many people have drinks? So that would be total 89. Out of how, not the total now, the odds are or what I want over what I don't want. So the people who didn't have a drink were 16. So it's 89 over 16. All right, whatever that is. Okay. All right, so that's two-way tables. They can really help with probability. All right, I'm going to clear this. And let's go down. Okay, and that's it for today. All right, so that's that for this lecture. So you'll have one lecture on the basic equations, and you'll have this lecture on two-way tables. All right. All right, so I will talk to you later. All I gotta do is figure out, there we go.